Hello, we are given the unit circle below, and we want to locate where pi radians is. So if you remember, we always start out on the positive x-axis, and this is 0 radians. It represents 0 times around the circle. We do know a full circle is 2 pi, and pi is half of a circle. So pi, we're going to go around halfway, and we are going to get to, oh, how did that happen? There we go. We're going to get to pi right over here. Now we want to figure out where 3 pi is. So if 2 pi is a full circle, 3 pi is more. In fact, 3 pi can be split up into a full circle, right? 2 pi is a full circle plus 1 pi, because 2 plus 1 is 3. So if 2 pi is a full circle, we're going to start at 0. We're going to go all the way around, and then you add pi to it. So after you go all the way around, you're going to come back half a circle more, and you're going to end right where pi was. Okay, so 3 pi is a circle and a half. What about 5 pi? That's really large. So 5 pi can be broken up into 1 full circle plus 1 full circle, and then you have half of a circle left over. So we go around the circle once, we go around the circle twice. This looks ridiculous. And you end in the same spot as the others. Because the point is, although you're going around the circle multiple times, you still end in the same spot. And that's actually really important, because what we call that is a coterminal angle. So terminal means to end, and co means the same, like co-workers, you guys work together. So coterminal angles end together. Now, coterminal angles are angles in standard position, that just means they start on the right side, that have a common terminal side. They all end on the left side, all in the same spot, on the x-axis. So we call them coterminal angles, and we can actually use that to our benefit. So how do we actually figure out if 2 angles are coterminal? They just have 1 full circle in between them. So for example, let's go back to that last question. 7 pi over 6. So if you were to draw this out, 7 pi over 6, you should have gotten that 7 divided by 6 is more than 1. So this is more than pi. 7 pi over 6 is like over there. Now, let's try and figure out what is coterminal to it. So if 7 pi over 6, I'll even mark it off. This is 7 pi over 6. What happens if we go around the circle again? If we go around the circle again, where are we going to end up? Well, around the circle again would be adding 2 pi, because we're going all the way around, and the full circle is 2 pi. So in order to find a coterminal angle, you take what you have and you go all the way around the circle again. Now you do have to be able to add that together, and in order to add 2 fractions together, you need to make sure they have a common denominator. See how our denominator is 6? You need to multiply by 6 over 6. So you get 7 pi over 6 plus 12 pi over 6. You keep the denominator and you add the numerators. So this becomes 19 pi is going to be coterminal to 7 pi over 6. And that's going to come into play tomorrow. How we're going to see it, though, is we're going to be asked, an angle measure of 7 pi over 3 radians is drawn in standard position. In which quadrant does the terminal side lie? So, if you take a look at it, to have our x, y axis, we know 0. We know pi over 2. We know 3 pi. Sorry, that one's just pi. 3 pi over 2 and 2 pi. 7 pi over 6. Let's see, 7/3. 7 divided by 3 is about 2.3 repeating pi, right? So that is more than one full circle. And if you realize that you're more than one full circle, that means we can find a smaller coterminal angle. Anything that's greater than 2 pi, we're going to try to measure down to a smaller angle that we'll be able to comprehend. So we're going to start with 7 pi over 3, which is more than one circle. That's just too much for us. So what we're going to do is we're going to go backwards and we are going to subtract a full circle. We're going to try and subtract them, so we need to get the same denominator. Well, if this is a denominator of 3, we need to get the right side to be a denominator of 3. So now we have 7 pi over 3 minus 6 pi over 3. We end up with pi over 3, 1 pi over 3 really. And what we're going to say is 7 pi over 3 and pi over 3 are, oh, that was weird, are coterminal, meaning they end in the exact same place. Instead of using 7 pi over 3, it's a lot easier to use pi over 3 because pi over 3 is less than pi over 2. I mean, guys, 1/2 is less than 1/3, right? So that means we are going to be somewhere. Why is my cat? That's weird. That means we're going to be ending somewhere between 0 and pi over 2. We're going to be ending somewhere in the first quadrant, so quadrant 1. Yeah, hopefully it works or makes sense. Try it again. In what quadrant does the terminal side 13 pi over 4 radians lie? Now, if you need help comparing 2 pi, we're going to put it in terms of a denominator of 4. So if you multiply 2 pi over 1 times 4 over 4, that way we have the same denominators, it's 8 pi over 4. A full circle is 8 pi over 4. We have 13 pi over 4, so this is more than a full circle. I mean, if you put that in the calculator, 13 divided by 4 is more than 2. So we don't like that. So we're going to try to find a coterminal angle. We have 13 pi over 4. Let's subtract a full circle. Maybe we could compare it to something easier. So in order to subtract, you need the same denominators. So to get the same denominators, you multiply by 4 over 4. Realizing I just did this before and erased it, it's so unfortunate. We have 13 pi over 4 minus 8 pi over 4. You have the same denominators, so you just subtract. You end up with 5 pi over 4. So now instead of working with 13 pi over 4, we could work with 5 pi over 4. You're going to go back to your xy axis, and you have 0, pi over 2, pi, 3 pi over 2. and 2 pi. Now, 5 pi over 4. There we go. 5 pi over 4 is about 1.25. Remember, it goes 0, half pi, 1 pi, 1.5 pi, 2 pi. So 1.25 is between 1 and 1.5. That means it's somewhere over here in quadrant 3.